Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving QuadMax by Philip Newman. This is part of our August guessing game. So if you think you have an idea about what tomorrow's variant might be, post it in the comments, and if you get it correct and you didn't cheat and look ahead, because these videos come out a day after the puzzles, then you win yourself a bonus cowboy hat. Either way, let's solve the puzzle. So today's gas is a QuadMax Sudoku. So we have normal Sudoku rules. We're placing the digits 1 through 9 once each in each row, each column, and each outline 3x3 region. And on top of that, we have these circles with arrows in them. And the direction that the arrow points shows you where the highest digit out of the 4 surrounding digits is. So for example, because this is a 6, but the arrow is not pointing to the 6, this digit has to be bigger than a 6, so it's 7, 8, or 9. The one thing to note about this, some of our arrows are on region boundaries, like this one or like this one. In that case, the highest digit is always unique. So if there, for instance, is a 9 that the arrow is pointing to, there can't be another 9 somewhere else in those 4 cells. There has to just be one unique digit. But the other smaller digits aren't necessarily unique. Like this could be a 3, for example, and that would be fine even though there are 2 3s there. So I placed that 7, 8, or 9. It actually can't be a 9 because it is not the highest digit out of these 4, so it can only be a 7 or 8, and then that's going to be an 8 or a 9. Okay, we're going to do a little Sudoku at the beginning of this. So we have 2 5s here and a 5 here that give us a hidden 5 in this region. We know we have a 6 in one of these 2 cells based on these 2 6s here, ruling 6 out of those cells. However, this can't be our 6 because then we would not have a unique highest digit, so this must be our 6. We can place some 1s, so there's going to be a 1 right there. There's going to be a hidden 1 right there. We're going to have a 1 in one of these 2 cells. However, 1 can't be the highest digit out of these 4, and the arrow points to that cell, so that can't be our 1. And that's going to be our last 1 in the grid. There has to be a 4 in one of these 2 cells. There has to be a 4 here by Sudoku because there's a 4 there and there. And so there has to be a 4 here also by Sudoku and here, and that places a 4 right there, and I believe that is all of our 4s. There are 2 6s here, ruling 6 out of these cells, so there's a 6 in the very central cell right there. And then there's going to be a 6 in one of these cells, and there's going to be a 6 in one of these cells because of these 2 6s. That actually rules 6 out of this because we've already accounted for the 6 in column 7, so this is going to be a 6. And we have a 6 here, we have a 6 here and here, so 6 is going to have to appear in one of these 2 cells as well. Now these guys both have to be bigger than 6, so these are from 7, 8, or 9. These are also both from 7, 8, and 9 because they have to be bigger than 5 and 6 respectively. But this cell has to be smaller than this one. So this can't be a 9, and this can't be a 7. Now, these both have to be smaller than 6 because the 6 is the maximum digit here, but they can't be 1, 3, 4, or 6, so they are 2 and 5. And now these are going to be 3, 7, 8, and 9. This can't be a 3 because there's a 3 in the column. Neither of these guys can be 9 because they are not the highest digit out of these. So we can eliminate 9 there. And because we know there's a digit in this 4 that's either 7 or 8, this has to be bigger than that. So this has to be either 8 or 9. That places our 6 from earlier there and places another 6 here. So now we've finished our 6s. This guy also has to be the biggest digit in its 4, so it can't be a 3. And it can't be a 7 because that would make it smaller than the digit in this cell. So it must be an 8 or a 9. There's only one place for 2 remaining in this column, it's right there, and there's only one place for 2 in this region, which is right there. And that means there's going to be a 2 in one of those 2 cells because those are the only positions left for 2 in region 4. However, the 2 can't go there because it's not the biggest digit in these 4. So we're going to put a 2 right there. That gives us a hidden 2 here, and another hidden 2 here, and now a 2 in one of these cells, a hidden 2 here based on those 2s, and a hidden 2 here, which places a 2 right there. So we have now all of our 2s. There are a lot of kind of floods of getting all of a particular digit at once in the course of solving this puzzle. We have 3s here and here. That places a hidden 3 in this region. There's also a hidden 3 in this region. That's the only position that 3 can go in that region. And I think that that's all we can do for 3s right now. There's a 3 there or there, and there's a 3 here or here. This cell, though, this can't be 7, 8, or 9. This actually has to be our 3 because it must be smaller than 5. So that's going to be a 3. This is now going to be a 9, and we can place our other 3 right there. So the last digit in this row is going to be 5. And because we have 1, 2, 3, 4, 5, 6 now in column 3, we're going to go ahead and fill in the rest of the digits with 7, 8, 9 pencil marks. This is also 7, 8, or 9. These are also 7, 8, or 9. And this is 7, 8, or 9. We can do a little bit of work with this. For example, this can't be 7 because it has to be bigger than the cell next to it. So that's going to be an 8 or a 9, and that's going to be a 7 or 8, meaning one of these contains a 9. So this is not a 9. And so now we have a 7, 8 pair, which makes this a 9. So we can eliminate 9 from this cell, and we can eliminate 9 from this cell. These guys are also from 7, 8, and 9. This can't be a 9 because it has to be smaller than this. And similarly, this can't be a 7 because it has to be bigger. So that gives us an 8, 9 pair here, which places a 7. And now neither of these can be 7s. This is now a 7, 8 pair. And because we have an 8 or 9 there, that must be our 9. And that resolves a bunch of our high digits here. This is now a 9 because we have an 8 in the region. And I'm just finishing up with some Sudoku for now. I need a 7, 8, or 9 here, but it cannot be a 9 because that would have to be the highest digit in this 4 has to go there. So that's not a 9, this is my 9. And now this has to be lower than that. So this is going to be a 7 and this will be an 8, and that resolves this pair. These guys are going to be 5, 7, and 9. So that's either 5 or 7. That's 5, 7, or 9. That has to be an 8, making this a 9. So these are going to be 5 and 7. So now I do know that this is a 9. This is either 5 or 7, and this is an 8. And now the last thing I'm going to need is to identify some way to figure out our very last disambiguation, which is going to come from down here. We know that the 6 is the biggest digit. 5 is smaller than 6. 7 is bigger than 6, so it must be 5 to be smaller than the 6. And that will let us finish the rest of the digits in the puzzle. Hope you guys enjoyed that one. I thought that was lovely. If you want to solve it yourself, the link is in the description of this video, and I will see you again in a few days.